Welcome back, ladies and gentlemen. We're going to be doing a little bit of a lesson about circular motion. And here's the wonderful thing about good old circular motion. See, up until now we've been talking about linear motion, things going in a straight line like this. But now we're going to be talking about moving in a circle. And the wonderful thing about circular motion is that the answer to circular motion is always the same. It's a circle. Why is that thing doing that weird thing? Why is this object doing that weird thing? It's a circle. Why is it traveling in that unusual path? Because it's a circle. How is it doing it? Well, it's a circle. But what speed is it going at? It's going at circular velocity. But what position does it have? It's got a circular position. What acceleration does it have? It has circular acceleration. It's always circle for every single question and for every single answer. But in order for us to talk about circles, which you're going to get tired of hearing by the time we get to the end of this, we do need to put down some basic ground rules. Okay? So first things first, we're going to only be dealing with what we call uniform circular motion in this particular course. So uniform circular motion. Well, we know what circular motion is. It's this thing that I keep holding up. But what is uniform again? What does that mean? You know what uniform means. Uniform means that it's staying the same. It's not changing. So if it's not changing, that means that this thing has a constant speed. And speed is key here, as we are going to see as we go through this. So we have a constant speed. The other thing that we have to understand when it comes to circular motion is the idea of a cycle. A cycle is one complete revolution. So, what do I mean by one complete revolution? Well, this wonderful circle I keep holding up, I start right here, and I go around the circle, right back to where I started. That is a complete revolution. I got from where I started to where I ended, and it's the same place. So, obviously, if I do this twice, that is 2 complete revolutions, or 2 cycles. All right? Makes sense so far? Cycle, going around the circle. Obviously, we need some way to talk about going around the circle. Also, as obviously, the phrase cycle is a particular piece of terminology to the circular unit. You could just describe going around the circle as going around the circle, just like I just did. But if you know what the word cycle means, you get to cut out a lot of extra work. Now, the other 2 things that we need to look at are, we're going to see, very similar. The first one is called period. And the second one is called frequency. If you've got any audiophiles in the class, that's people who really are big on music, then they probably have heard frequency because they've heard about such wonderful things as, headphones and the frequency of sound, because frequency is related to sound. Now, the exact method that is related to sound is sort of a little outside our wheelhouse. We don't talk about that in grade 11. We talk about that in grade 12. But, I'll mention it here and there as we go. So, period has many different symbols. Usually there's some variation of a T. I usually use this kind of T, sort of a angled T with some little hatches on the side. Frequency also has many symbols. I tend to use this one. This is the Greek letter nu. It's related to the other letter mu that we've already dealt with before. It's the next one in the alphabet. Mu is the Greek letter for M. Nu is the Greek letter for N. Right? M-N-O-P. We're not getting into O's and P's yet, I'm afraid, but we're learning a little extra Greek as we go. Now, you can also, in frequency, use an F or a cursive F, and you'll remember that those are the same kind of symbols that we use for friction. So there's a little bit of overlap in that area. Okay, so we've got ourselves a symbol, we've got ourselves a name, but what is it? Well, period is seconds per cycles. And frequency is cycles per seconds. Well, that looks very similar now, doesn't it? But, okay. What's going on? And I thought frequency was related to Sound. Where's the sound connection? This one here can also be called Hz or Hertz, named after a guy who pioneered a lot of these equations originally. You know you've done well in science when they name something after you. No, there is nothing yet named after me, I'm sorry. Okay, so this is the basic idea. So what you'll notice here is that period and frequency are related, and they're related because they're both basically the same thing, just mirrors of each other. And they're both equal to time. They're just equal to time in a circle, right? In a normal straight line linear thing that we've dealt with up until now, represented by this wonderful ruler, I don't have to worry about describing the straight line, the time of a straight line, because we just say, okay, I start here, I go over there, and I'm done. But in the case of a circle, it matters. How many times have I gone around? Where am I in the going around process? Because each time I get to the end and start to go around again, it's going to change things, right? Whereas here, it's super obvious that I'm getting further and further and further from my reference point. Well, here it's not so obvious because my reference point is a circle. So it goes around, whoop, back to my hand. So we need to find some way to talk about it, and so they build that into the calculation of time. Let's do an example. Okay, examples always help. So we've got a couple different examples we can do. I've got some written in the notes, of course, and I do, of course, recommend that you guys read through the notes as we're doing this, because there's no point in you guys copying them out twice. I'm just talking about this to make sure that we, understand things, so I can add some nuance and things. Okay, so let's take a look at example 1. I'm going to do 10 cycles in 5 seconds. Okay, so that means in 5 seconds, I'm going to go around the circle 10 times. I'm going to start here, and I'm going to go 10 times in 5 seconds. It's pretty quick, right? So what's going to happen? Okay, well, if I ask you what is the period, and I ask you what is the frequency, well, you can do both of them, because the period is seconds over cycles. I've just shortened them here to S over C. And the frequency is cycles over seconds. I could do both of these at the same time, right? This one here is just going to be 5 over 10, and this one is 10 over 5. That's almost a 5. So this one is going to be 0.5, and this one is going to be 2. And this one here I could write as either cycles per second or second per cycles. But to be honest, physicists are a little lazy, especially when they can get away with it. So they usually don't bother writing the word cycle because they know that cycles are involved, right? It's like, I don't have to tell you that hello is a greeting, generally, because you know that hello is a greeting. So there's not much point in me saying hello as a way of welcoming you, because that's unnecessary information. Similar, a physicist would know that frequency means cycles per second, so why bother writing down the cycles part? Similar, we know that period is seconds per cycle, so why write the cycles part? So what usually ends up happening is that they actually write it like this. Or, in the case of frequency, they might sometimes write it like this. The -1 is the same as saying flip it down like this. Or, if they really wanted to be lazy, they just go like so. So this is just another way to write the answers. Okay, so there we go. There was a simple example that we did. Let's do another one. Days for Earth to go around the sun. Oh, okay, I'm asking for days, not seconds. Seconds would be messy, but all right, let's think about it. Instead of seconds, we'd be days. Okay, so days over cycles for period, and frequency would be cycles over days. Okay, how many days in a cycle? What would we call a cycle of the Earth around the sun? All right, here we go. We got our circle example again. Here it is. And I put the sun in the middle. There's the sun. And when the Earth goes around the sun, what do we call that? Oh, we call that a year. Right. Oh, yeah. So how many days in a year? That's what I'm asking you. Hopefully you know that. Hopefully. 365 for 1, and it's 1 over 365. Okay. Now this 1 over 365, like 365, that's just 365 days per cycle, of course. The per cycle is, of course, not listed. We erased it. So that one's easy. Well, this one here's not so easy. I can't put it as 1 over. I've got to divide it. So I got to take out my trusty calculator because I can't do that in my head. And I go 1 divided by 365. And I'm going to get, this is 0.0027 days to the minus 1. It's not hertz because it's not seconds. What's going on here? Okay. 0.5 seconds per cycle. That means that in order to do one cycle, it'll take me a half a second. 2 cycles per second. That means that I will be able to, in 1 second, go around twice, which makes sense, right? If I take half a second to go around once, then I can go around twice in 1 second. Now let's look at the time for going around the sun. 365 days for 1 cycle. That's 365 days for 1 year. 0.0027 days to the negative 1. What that means is that in 1 day, I will cover 0.0027 of the total circle. So what I'm kind of saying is, if we look at this again, this example here, I started here, and in 1 second, I go to down there. In the case of the days, what I'm saying is I start here, and in 1 day, I go that far. That's still super weird, right? Like 0.0027 days to the minus 1. That's not helpful. That's not useful. What am I going to do with that? That doesn't mean anything, only if I really think about it. In a similar vein, this one is not the best. Like, it's okay. Half a second for one spin around. It's all right. But it's still kind of, it's kind of unclear. And that's kind of the thing we see here. The reason why there are 2 different ways to talk about time in circular motion is because each one of them is good at different things. Frequency is really good at fast things. Period is good for slow things. The Earth is slow. It takes days to go around the sun. My little example here is pretty quick. It takes multiple cycles in 1 second. Now, your case of headphones and other things like that, sound. Sound will have frequencies listed in thousands of hertz. What that means is that there are thousands of cycles per second. Right? If you've, let's go with another example rather than sound right away. Car, right? Some of you have cars. You've got the RPM meter in your car, the revolutions per minute. That's cycles per minute. That's how fast the motor is going, how fast the motor is turning, right? Your car isn't moving slowly. It moves very quickly. Parts inside your engine might be going at hundreds of revolutions per minute. Similar, sound, back on that, sound is made by pressure, air coming in inside your ear, and they hit your eardrum. And they hit your eardrum at the rate of thousands of times a second. A second. And that's how you can hear things. There are certain things that do not hit your eardrum fast enough or often enough, and those are considered non-audible, or things you can't hear. A dog whistle, for example, involves sounds that your ears can't pick up because they are not moving at a frequency, a repetition, a pattern that it can pick up. So what we're going to see here is that for circular motion, things are actually really straightforward because the answer is, as I mentioned, always circle. The key thing is figuring out how to translate what we already know, like for example time, into talking about circle. And we see here, time is either period or frequency, and they basically say the same thing. They're just time. But they're the question of time it takes either for this to go around once or the amount of times that I'll go around in 1 second. Okay, so that's the basics. I'm now going to immediately make another video about velocity, and I'm going to make another one about acceleration in order to make sure you guys have the most information possible. Okay? All right, so I'm going to cut it here, and then I'll put up another video right afterwards with